Hello, lecturer and everyone here. I'm the first person to represent our graduation thesis. So the topic is research, design, and verification of firefighting one-copter. So our team has three members: me, Woodward, and Jonathan. So our presentation involves 5 sections. First, overview. We will introduce generally our project proposed method. We're talking about the method that we find to solve a problem, the solution that we clarify how we find out to control the UAV firefighting result. We say about the experimental, the success and failure lead to product. And the last is the conclusion. For the conclusion that we discuss about platform result and we review what we achieved, what we to improve, and the future direction. For the first, come to May 2024, Vietnam has experienced over 400 fire incidents and almost occur in the urban because of high population density and extreme infrastructure. So let's see into picture. When the same situation, whole picture is highlighted about the difficulty to getting entrance of fire location. For the first picture, that the fire occurred in the high department. And for the second picture, that describes the fire location occurred in the narrow alley. So, what is the effective method to extinguish the fire? There's some traditional method for extinguishing fire. We can use fire truck, chemicals, sprinkler system, or fire blanket. But each of them has its advantage. For the weather, that it can lead to damage the property. A chemical can risk to your health or harm to the environment. For fire truck, you have to invest for installation and maintenance. So, and in the last year, that when we try to find out the research, we try to find out the effective way to extinguish fire, that we come across this competition. For in this competition, that we use a drone to throw the ball to the traffic area. So based on this concept, we decide to develop a UAV firefighting to throw the ball to extinguish fire. And up to right now, that UAV applied in many various fields, like the military, that they use a camera on the drone to detect the crime and ensure safety in the area. For a study that they gather information to visualize for understanding scientific. For rescue, that the drone has ability to navigate dangerous zone like earthquake or fire. And also that the UAV used a lot in commerce or entertainment. And we're talking about the hardware details. UAV is constructed a lot of components, and there's some very essential components like for VL's present motor that is give a thrust to a drone lift up. Or you can see that is a big sock. A big sock is like the brain of the drone to control on-form models. And also that is contain a lot of sensor like acceleration sensor or parameter. Our system node is the place to contain an execute output code. And also that is the place that process and analyzes the frame from the camera. And the special one is a Reaper. It is created by our design and fabrication. Its tank is hold and release the bonfire, the fire stimulus bone. And for calculation and selection, the component our drone that we did our traffic research direction by two method, design and controller. For research drone, that total weight up to 4.2 kilometer, probable length from 254 millimeter to 305 millimeter. With moving speed is maximum about 5 meter per second. We approach with four methods. The first, document search method, experimental, synthesis analysis, and consulting by the expert. So in the next presentation, please define.
So here we have a block diagram of our firefighting drone. So firefighting drone system consists of interconnected units. These units are connected by two pairs of lines, a power line or a signal line. So here we have 6 types of units. At the heart of the diagram is the flight control unit, which consists of a multiple of sensors and a main processor. Also, we have the drive unit, which has an AC for VLE, for process, DC motor, and propellers. And next, we have the communication unit, which houses an RC transmitter, which will transmit control signal to the flight control unit. And also, we have the ground control station, which we can use to monitor our drone in real time. While our flight control unit serves as the low-level controller, our output module will handle a higher-level task. This output module consists of just a nano companion computer, and this computer will be connected to a camera to help it detect the plane. And the computer will send out control signal to the gripper unit, which has a battery for 12 volts, an H bridge driver, a gear motor, and finally a limit switch. And finally, the power unit. The power unit will have a 4S lithium battery that will power the motors and the flight control unit. This power will be transmitted by the power distribution board to distribute power equally to every components. And also for the Jetson, we use a buck converter to regulate the voltage down to 12 volts. Next, I will present the test we use to create our custom yellow model to detect the plane. So first, we downloaded the GitHub repository of the yellow 9, and then we installed the required libraries. Next, we download the pre-trained model of yellow 9 called yellow 9e. After that, we train our model with our custom fire data, and finally, after the model is has enough accuracy, we save the base model as a PD file. And over here, I would like to present our gripper mechanism. So on top of the gripper assembly is the motor itself. It is a GA3C70 motor. The motor is will present the system process of our file tracking control. So first, the camera will capture video at a frame rate of 60 fps. Then images from each frame will be set to the JSON nano to be cropped and then inputted into the YOLO demand model. And if the contents from the detection is over 75%, the JSON will create set point condition toward the UAV and it will send it to the pixel. And the pixel will put a drone course on the plane, and when the drone gets to the location of the plane, it will tell the JSON nano to control the gripper to release the ball to extinguish the plane.
So we talk about the voice and animation. Send out to you a lot of validation, so we should you geometric formulas to calculate distance and to control version about the that you see in the slide. I represent the A in the point of the position of the vector, K in point of the position of the plane, and the distance a straight line connecting from vector to the plane is with this distance about n meter. The horizontal field of view of the camera is about 1780 degrees, which is 720 decimal frame. So with all the parameters above, we can easily apply trigonometric formulas to find the relationship between the movement of the vector on the horizontally CV and the chain of the displacement on the frame. So each time the vector moves to the left or to the right for distance about 0.0225 meters, movement 1k move 10 decimal CV. So we found the relationship between the movement of the vector and the chain of missile in the displacement is distance from vector and plane, but we don't know that distance. So we have to find out the relationship between the distance z and the height of the f that can be read on bit of CC on the automation sensor. We see that camera is facing on vector with the angle about 45 degrees related to the vertical direction. So we can find out the relationship is 0.0225 meter is equal with 0.022 meters. So the find out is we can also know that each time the vector moves to the left or to the right for extent about 0.032 meters, we will make the we move 10 decimal speed and have from a to previous slide. Now we have to find the relationship between the movement of the vector forward or backward and the chain missile in the vertical direction. We have a vertical field of view of camera of camera is about 65 degrees within 100 pixels in frame. By the distance of the vector to the plane, if you limit the vertical field of view by the segment LM. So we correct on about the parameter and this will apply basic geometric formulas to find out the relationship between the movement of the vector on the horizontal KX and the chain of pixel on the segment LM is each time the vector move forward or backward with distance of 0.0288 meter, equivalent 1 and 10 move 10 is on segment LM. So the position has been calculated for a vector to move so that the center of the plane is in the center of the screen. We will create a set point for vector like as follows. In the equation, we have SD and YD is the design position of the vector. SC and YC is the current position of the vector, and your goal is your goal that created by the vector and the always AC. Okay, since because the controls signal for control is the position is Y, Z, and your goal. So our team use a PV controller attitude to calculate the set form S Y, and Z. After passing through the first V blocks, will respond to velocity. The error velocity after passing through the second V blocks will reduce into K. We use the attitude controller, the output will gradually reduce. After using dynamic formulas having developed in the river, we often use the first of the judgment, the quarter fly or fly down, and decide usually the first that the quarter balance. For the position controller, the output is the signal US and UY. After using the dynamic formulas have been developed in the river, we will have the raw control and control. So we go to the result. Here you can see in the plot, we have the run code with the hardware loop simulation. Our team will treat code to run on the program or our long-term one. First is the off node. This is the code our team use create a set point to run the program using the function 21. Fire detection node is the code that our team use to open the camera, lock the model, and to detect flame. Motor control node is the code that our team use to open or close the grip arm. So this OCC have various macro tools that we can use to read the sensor and the data status. You can see the arrow is start from the topic and ready to the upload. That's showing the topic how to use to read the sensor. First, velocity local. This is the topic that we use to read the linear velocity of the motor when moving in always Y or Z. The other sensor that will show us the current position of the propeller, the target attitude, and the state is the topic how to use to read the status of the propeller. In that case, it's upward or position or manual. The OC is a topic that reads the signal from the joystick. Contrast will make us see beyond the in addition, we will have another topic from another code is fire S and fire Y. This is the coordinate and center frame region with the center of the screen. So after collecting all the parameters, this will calculate radius circle and put this to the attitude node. Attitude topic. This will control the culture to position for calculate in in addition, we will put this another signal to the motor control node to release the fire distribution rule. So that this is the SIG graph represent for XYZ roll with your computer when you're running in the hardware loop simulation. You see that a graph with blue background is the time we turn it to the off-board. This time we turn to running by default. Other time we off-board, the computer immediately turn to the right, turn to the left for degree about 60 degrees because the lack of the rest of the fire detection. So if we rotation until the camera having detected that it's a have the flag in the screen, the computer will stop the rotation. And then we look at the S and the Y graph at the time. The computer having detected the flag, because the flag is the left side of the screen, we will make the computer move to the left. Then we change the flag to the right side of the screen. We make the computer move back to the right. All the brain will continue until the computer ensure that the flag in the center of the screen. At the time, we will spend about 6 seconds to ensure the flag center point in the center of the screen, so that we will fly to the location of the computer and stay on it. Then this is the result of the real flight. At other time, outing turn the propeller to the upward because the camera having detected there is a plane in front of the propeller, so that is do not roll the angle propeller. So because the propeller is in the left side of the screen, we will make the propeller move to the left. After that, we change the plane to the right side of the screen. The propeller will move up to the right, and the propeller will take about 6 seconds to make sure that the propeller is the plane in center screen propeller, and that it will fly forward to the location of the plane. In this time, we will release the fire extinguisher ball, and after that, we will move back to the position that plane in the center, because if it stays too long in this place, it will be very dangerous because the hot air of plane. So this is a video of the experiment.